Okay. Use the tangent line equation from part A to approximate f of 1.1. The idea is very, very simple. You have f is the curve. The point where the line is tangent is x equal 1, y equal 2. Therefore, if this were a very enlarged photo, we would say x equal 1.1 is maybe here. So that would be x equal 1.1, and then the y coordinate would be f of 1.1. I'm running out of room here. Well, they want us to find not the blue dot, they want us to find this pink dot here on the line itself. So the equation for y is how I find points on this line. That's how I'm going to approximate f of 1.1. 1.1, that's not really helping. So I write down over here f of 1.1 is approximately 8. The x coordinate that I'm plugging in now is 1.1. And that's it. Numeric simplification is not required. So if I get that far, they will give me 1 point. So I've done that. Use the use the tangent line equation for part A to approximate f of 1.1. I did that. Given that f of x is greater than 0, so f is positive from 1 to 1.1, is the approximation for f of 1.1, is this value greater or less than the actual value? In the picture, our approximation is definitely greater than the actual value. And that's because f in the picture is concave down. If f were concave up, the opposite would be true. So that's how I remember to figure out whether the approximation is greater or less, is I need to find concavity. Well, f is concave up or concave down based on the positive or negative of f double prime. So without a graph, it's hard to identify increase, decrease. So we're going to use this. So I take my f double prime here. So I'm going to go find the second derivative at x equal 1, y equal 2. Which is going to equal, let's see, the y value would be 2 cubed, 1 plus 3 times the x value times the y value. That's a positive number. So I don't have to go any further. I can just say equals positive. And then I can use this statement on the back of the golden notes to get the second point. So I write, I've done this already. I've found the second derivative is positive. Therefore, f is concave down concave up. That's a mistake. Concave up, which means you have this sort of a picture. You have concave up, and then your tangent line is going to lie below. So therefore, fx is concave up, so the approximation approximation lies below the curve, so less than the actual value. The actual value is f of 1.1. If you have this in blue, all of it, you get 1 more point. This is worth understanding. It's not a hard problem. All you have to remember is when we're talking about whether a tangent line approximation is greater or less, we're simply looking to see is the curve we are approximating concave up or concave down.